Good morning, Booth Dog here, taking proper precautions as always. Um, Speaking of which, if anyone knows any way of wearing a mask without fogging up your glasses, do reach out and let me know. It's getting quite annoying. Anyway, I just want to jump right into our lesson for today and briefly remind you that we're almost at the end. I know this has been such a long quarter. We're kind of tired and we're ready to just be done. And we're not yet. We're almost there. Just push yourself a little longer. I know I'm going through it too. We'll come out on the other end of this, okay? Let's go to our lesson. Good morning. So you do have an exit ticket due by midnight tonight. Remember that today is all about some practice. So look at the problem, pause the video, work through the problem, come back to this and go through my answer and check your work. So we have a function f of x equals, it's a piecewise function, x squared minus 1, and that happens when x is less than negative 1. And when x is greater than or equal to negative 1, we're looking at the piece of the function that's 1 plus x. All right, now we have two questions here. First, find the limit as x approaches 2 of f of x. All right, so when x approaches 2, which piece of the function are we considering? Is 2 less than negative 1 or greater than or equal to negative 1? 2 is greater than negative 1, so we're considering the second piece of this function, right? As x approaches 2, we're looking at the second piece of this function. Does substitution work here? Can we just plug in 2 here and get an answer? We can. So substitution worked. The difficulty here was just understanding which piece of the function we're considering. And that is just based on this. We're approaching 2 that's greater than or equal to negative 1. The second part here, it's a little trickier. That's why I really wanted to go through this with you. The limit as x approaches negative 1 of this function. Now, remember, and this goes back to the very first thing we discussed with limits. In order for a limit to exist, we have to be approaching the same value from both sides of that number. Right? So if we just have a parabola or a function here, as we approach this value from the left and from the right, we're approaching the same function value. So that limit exists. Okay. If we're considering a function like, I don't know, let's say our function looks weird and it jumps from there to here. And some of our piecewise functions do look like this. Well, as we're approaching this x value from the left and from the right, those are different y values. So that limit would not exist. Again, that's going back to our very first day of limits. So here at negative 1, that's where this piecewise function is split into more than one piece. So in order for this limit to exist, okay, we need to make sure that the limit as x approaches negative 1 from the left equals the limit as x approaches negative 1 from the right. All right, and so kind of like what we did for part A, negative 1 from the left is that less than negative 1 or greater than negative 1? Well, if we're to the left of negative 1, that's going to be less than negative 1. So we're looking at this piece of our function. Is that equal to the limit as x approaches negative 1 from the right? And to the right of negative 1, we're dealing with x values greater than negative 1. So we're looking at the second piece of our function here. And now we use substitution. So we plug in negative 1. Negative 1 squared minus 1. Does that equal, plug in negative 1, 1 plus negative 1. Negative 1 squared is positive 1, minus 1 is 0. 1 plus negative 1 is 0. So since these two limits from both sides are the same, that means the limit as x approaches negative 1 of f of x exists, and it equals 0. Okay,
so this right here, very tricky. I totally understand. This is more of a highly proficient kind of question. But hopefully you followed what I just did, and that comes directly from our very first definition of the limit. The limit from the left has to equal the limit from the right. Okay, so we have this work here. So go ahead, check your answer. Next problem, now we're dealing with a graph. Consider the following graph of g of x. Okay, so I'm just going to zoom in here. Now, part A, find the limit as x approaches -1 of g of x. All right, so the limit as x approaches -1, so we're looking right here. And again, anytime we're dealing with these limits, okay, does the limit as x approaches -1 from the left of g of x equal the limit as x approaches -1 from the right of g of x? Well, as we approach x equals -1 from the left, that means we're coming from this side. And as we get closer and closer, what value is that? Remember, limit is a function, it's a y value. So what y value are we approaching as we get closer to -1 from the left? That's the y value of 2. As we approach -1 from the right, so that's down here on this piece of the function, as we get closer and closer, what y value are we approaching? Y equals -1. So since the limit as x approaches -1 from the left of g of x, that's 2, and that's not equal to -1, clearly. So since this limit does not equal the limit as x approaches -1 from the right, then this limit as x approaches -1 of g of x does not exist. So again, this all just comes back to, and I know it's been like a week or two since we've talked about this idea, that's why this review, we're talking about it now. The limit has to be the same from both sides. If it's not, then our limit just doesn't exist. Okay? Those two values aren't the same, so we're not approaching a specific function value. Now looking at part B, find the limit as x approaches 2 of g of x. Okay. So it's the same idea. What's the limit as x approaches 2 from the left? And what's the limit as x approaches 2 from the right? Well, as x approaches 2 from the left, we're coming from this direction, and what y value are we getting closer and closer to? We're getting closer and closer to the y value of 0. And as we approach 2 from the right, what y value are we getting closer and closer to? Again, 0. So since the limit from the left equals the limit from the right, those are both 0, the limit as x approaches 2 is just whatever that value is, 0. Notice that's not the same as the function value. Again, this goes back to our first days of talking about limits. We're approaching the y value of 0. The function itself at x equals 2 equals something else. It jumps up here, that's y equals 2. But what value are we approaching? Y equals 0. Okay, very important. So again, check your work. Those are the more difficult questions. Now we're back to a little more basic, just evaluate. So the limit as x approaches 3 of x minus 3 over x plus 5. What are our methods for evaluating limits? First, we try substitution. Can we just plug in 3 for x? If we do that, we get 0 over 8, which is just 0. So substitution worked, okay? And our limit equals 0. If substitution hadn't worked, we would have had to try some algebra magic. If that didn't work, we'd just be kind of stuck at this point, until calculus at least. And our very last review question for today, the limit as x approaches infinity of 7x minus 4 over 2x plus 1. Anytime you see the limit as x approaches positive or negative infinity, we should be thinking about our horizontal asymptote rules. That's what this question is really asking. So looking at our function, is it top heavy, bottom heavy, or equal? This is an equal function. The degree of the numerator equals the degree of the denominator. So this limit, as x approaches infinity, of 7x minus 4 over 2x plus 1 just equals the leading coefficients. Okay. Why? Think of plugging in an infinitely large number here. At that point, this minus 4 and plus 1 don't make a difference at all. That means we're left with that huge number over that huge number. That's going to cancel out. And so all that remains is the leading coefficients. Okay. Same rules as when we talked about horizontal asymptotes last semester. So there we are. Check your work. Okay, especially those tricky ones where we have to consider approaching from both sides. I know it's been a little while since we've talked about problems like that. Keep practicing. Tomorrow, we will take our formal graded 9.1 exit ticket. Okay, this will be your last grade for the semester, aside from the culminating activity. Get that exit ticket done by midnight tonight and be prepared for your graded exit ticket tomorrow. Okay? Keep practicing with these problems, your 9.1 independent practice, and of course, continue to work on your culminating activity that's due in just over a week. Okay? Hopefully you haven't been putting that off. If you haven't, it's not too bad. Come to me with any questions, and have a good one.
All right, great as always. Please let me know if you have any questions. Join our Google Meet and make sure you're working on your culminating activity and any of your other final assignments that are due coming up. Otherwise, have a good one.